Hi, this is lesson 4.2, fundamental theorem of calculus, definite integrals, and calculator examples. I want to give you a quick little intro here to this because I think it's really important that you look at the velocity versus time graph to try to figure out some of these things and where they come from. So say, for instance, I have my drawing right here. It's kind of a crude drawing, but it is the velocity versus time. And so that means that my velocity here would be 3 units per second. So let's use meters and let's use seconds, just for an example. So if I go 3 meters per second for 3 seconds, that would be this region in here. So I have 3 meters per second, and I want to times by 3 seconds. That would give me 9 meters. That would be my distance traveled in this interval right here. Now I can find the area. The area gives me this 9 right here. More so, I can do that one right there, which would just be the area of the triangle, which would be 1/2, 3 meters per second times 3 seconds. And that would give me 9/2 meters. Now what happens when we go and we try to do this area? Well, now my velocity goes negative. That means that I am moving to the left. And so if I do the area there, it's going to be 1/2, 3 meters per second times 3 seconds, and that's going to be 9/2 meters as well. That would be a positive quantity, but really, since it's below the x-axis here, my velocity is negative, I'm moving left, and so I'm moving back 9/2 meters. So anything that's going to be above the x-axis is going to have a positive quantity. Anything below is going to have a negative quantity. And now what am I multiplying here? By the way, I'm multiplying v of t times t, and I'm getting my meters, which is my distance. Now more so, what if I tell you that my initial position is at 0? Well, that means that I'm going to be moving to the right up to here by 9 units. Then I'm going to go 4.5 to here, and then I'm going to take away the 4.5. So at s of 9, I am going to be at 9, which just means I added up these numbers. That's my initial position. That's my final position. Now here's what the definite integral does for us. The definite integral now will have limits of integration, which we'll say will go from 0 to 9. I want to find this area under this curve, and that is the integral that adds this up. I'll do an in-class activity with this, with Riemann sums, different things that will show you this better. But right now, this is just my intro. But I'm going to take the velocity and I'm going to multiply it by some time factor. Well, it's going to be a very small time factor, and I'm going to add up all these pieces, so I call it dt instead of just plain t as I did here. This right here gives me my net distance. Net distance traveled. Now the question is how do I get the net distance from here? Well, isn't this just your s sub 9 minus your s sub 0, which is equal to 9? I think it is. So if I look at this, the antiderivative, I'm writing this again, I didn't need to, but this is equal to the antiderivative velocity we know is the position function. And this thing, this net distance, I got s of t here, but I need to plug in different values. Well, I do plug in the 9 and I do plug in the 0. That gives me my net distance. So what we do is we put this bracket, the evaluative bracket, and we say that we want t starting at 0 up to 9. We evaluate this now, and this would be s of 9 minus s of 0, which is equal to 9. This is the definite integral. And what you'll do is you'll take the antiderivative. So the antiderivative velocity is the position function, and then you'll evaluate it from from the top limit minus whatever happens with the lower limit. These are the same things. That's all it is. It's very easy. So there's my intro. Sorry, it's kind of long, but I think it's good that you understand that before we get into this. So here we have lesson 4.2, definite integrals, calculator integration, the fundamental theorem of calculus. So the definite integral means that I have these limits. I have a lower limit and I have an upper limit of integration. And we can look at it as the signed area, usually from a lower limit to an upper limit, and between the curve, f of x, and the x-axis. The value may be positive or negative or 0. Unlike previous integration, which produced an indefinite integral, just the antiderivative, representing a family of curves, a definite integral tells us a number value. So when we have the lower limit, upper limit, we're going to get a number value. The calculator integration, I got to put in a different video because it doesn't work on this platform. So look for that on my website. Now on this one, make sure that you're getting this accurate to 3 decimal places. That's what we're looking for. I tell my students to just write down 4 because then you don't want to do intermediate rounding within a problem. You get more errors. And then you also don't have to think too much if you just write down 4. We only read 3 of them. So you choose what you want to do there. You can round or truncate to 3 decimal places. On this portion, this is old notation that they use on the TI-84. You should have the updated version, which does give the integral. You don't have to use FN int, and nor would you ever use this on some sort of test for communication because it's particular to the calculator, and it's not particular to calculus. This is the notation that we do want to use. So I'm going to do number 5, use the idea of signed area to evaluate this function right here without using a calculator. So if we do a little graph here, 2x minus 1, you find the 0, which would be 1/2. That would be your bounce back point. So here's a 1, here's a 2, here's a 3. My bounce back point is going to be 1/2. The slope is 2, so I'm going to go up here through 1, and that's going to be 1 piece. And then I'm going to go off here for my other piece. That's what my picture will look like. So I'm going to use an area interpretation to find the value of this integral. So I really don't even have to do this integral, but I want to do the area under the curve. So this one right here, I can find the area of that triangle. So the area of my first triangle is going to be 1/2 base times height. So it's 1/2, my base would be 1/2, and then my height is going to be 1. So this is going to be 1/4. My area of triangle number 2 is going to be 1/2 base times height. And then I'm going to get this base, which would be 2.5, and then multiply by my height, which I said was 5 right here because I plugged in the 3 into that function, the integrand. So I'm going to get a height of 5. So this is going to be 1/4 plus 6.25, which gives me a 6.5. That would be my answer. Sorry, I'm kind of sloppy there. A little tight on room there, though. So you can try this also on your calculator and see if you can get this same exact answer, either 6.5 or 13/2. Number 6, set up a definite integral which can be used to find this area in here. They give you the curve. It's bounded by the curve, goes down to the x-axis, so that sets up just perfectly for our integral. And then we go from 0 to 2. So that is my lower limit. That is my upper limit. And then here's my function, 2x squared minus 3x plus 2, which is the integrand. And then I got to multiply by dx. That is your integral that you're going to be using to find this area under the curve. Discovering the fundamental theorem of calculus, I'd like you to try number 7. I'm going to do number 8 with you, and then you also go ahead and do number 9. See if you can figure out what's going on here. So part A, find the definite integral from -2 to 1 of f prime of x dx. Notice that this is f prime there. They've given you that. Always look to see if that's f or f prime. So I'm going to find the signed area. So this one is below, and then this area to the x-axis is above. So I'm going to find the area of each one of those pieces. So if I do my red piece down here, that would be 1/2 times 1 times 2, 1/2 base times height. Why do I have this negative here? Well, yes, it's below the x-axis, so I need the negative on this quantity, signed area. Then for the blue here, I have 1/2, 2 times 4. This base is 2, this height is 4. So total, I get a net of 3. That would be the value of this definite integral. Part B says, write an equation for f prime. Well, it looks like it's a line that goes through 2. It looks like it has a slope of 2, so this would be y equals 2x plus 2. So there is my function for this. Now, I shouldn't have called it y. I should have called it f prime. Okay, so the f prime is equal to 2x plus 2. Find f of x if f of 1 is equal to 0. Well, we know how to do that. We take the antiderivative. And so this would be x squared plus 2x plus c. And then I know that this is f of x. And I know this initial condition. So 0 is equal to 1 plus 2 plus c. So c is equal to negative 3. So my function becomes x squared plus 2x minus 3. That is your particular solution. Remember, this is particular. This one is your general solution. Finally, in part D, they ask what is f of 1 minus f of negative 2. So if I plug in f of 1, I'm going to get 1 plus 2 minus 3. That's my f. So then I have f of negative 2. You plug in 1, obviously you get 0 because that's where we got from our initial condition over here. Plug in negative 2, you're going to get negative 3. So this is going to be equal to 0 minus negative 3, which is 3. Whoa, whoa, what's happening here? Wow, if I evaluate the upper limit in f and minus the lower limit in f, I'm going to get the same thing as when I did the area interpretation. Go ahead and try 7 and try 9. I'll post just the minor answers and then you can go through this in class. So the answers to number 7, you get 15 for A and D. See if you can find B and C and let's talk about it in class. I guess I'm doing number 9 with you. So given this is a position function for an object moving on the x-axis, find the displacement. So the displacement is the net distance. And so if I take the final minus the initial for my x position, I should get that. So I'm going to go x of 4 minus x of 1 is equal to, plug in 4, this piece right here becomes a 5, and this one becomes a 1/2. Make sure you check this, that I'm doing this right, and you can do this, which is 4.5 or 9/2. Then they ask, what is the velocity? Well, the velocity is the derivative of my position function. So I'm going to take the 2 out in front, and I'm going to get negative t, the 1/2 and the 2 cancel, plus 4. That's all. Then they say, sketch a graph of v of t. So I'm going to go up to 4. My slope is negative 1. The axis is off here a little bit. So then that's going to be my graph. And then I'm going to find the area from 1 to 4. So there's 1. There's my area. So if I go ahead and do that, I have a base of 3. I have a height of 3. So it's just going to be 1/2 base times height, which gives me my 9/2. Note, A and D are the same. Yes. So this goes back to what I alluded to. The antiderivative of velocity, and then if I do the definite integral from A to B, is simply my position function evaluated at the upper limit minus my position function evaluated at the lower limit. This is my definite integral. More so, maybe you have this f prime, and this would just be equal to f of x evaluated from a to b. So we say f of b minus f of a. That's the definite integral. Now let's get into some practice. And then I have that reiterated here. This is called the fundamental theorem of calculus. Let's get into this. We got definite integral. There's my integrand. So I want to take the antiderivative. Let's just rewrite this for a moment. 2y to the 1/2 plus 1 dy. So if I take the antiderivative of this, I need to raise to the 1 higher power, which is the 3/2. I already have the 2 out in front, so if I multiply by 2/3, that would be 4/3. And then I get plus y, and now this is going to be evaluated from 0 to 4. If I take 4 and plug this in, I get 4/3 times 4 raised to the 3/2 plus 4 minus 0, because if I plug in 0 into a polynomial, I'm going to get 0. Be careful, if it's not a polynomial, you don't always get 0. Then if I simplify this, this right here is the square root of 4 with that, and so the square root of 4 is 2 raised to the 3rd power now would be 8. So I'm going to get 32/3 plus 4. That's a 12/3, so I'm looking at 44/3. This is fun. Now number 11. Looks like I have an inside function. Uh-oh. So we have to do u is equal to 4t plus 1. du is equal to 4 dt. So I need a 4. I need to balance it off. So I'm going to rewrite this now as 1/4 the integral from, well, these things are a little bit strange, and so we got to be careful with that, and I'll talk about that a little bit later. But I'm going to get u to the 5th du. So I'm going to get u to the 6th over 6. I still have the 1/4, and then not plus c. I'm not going to do plus c, but I still don't know these limits. Why I don't know these limits is because this and this 1 and this 0, are in terms of t. This is a u substitution. I can't put u limits here because these values I haven't found yet. So I'm going to back substitute to t, 4t plus 1. And I'm going to evaluate. Now I can use the 0 and the 1. So I plug in the 1, I get 1 over 24 times 5 to the 6. Notice when I plug in the 0 here, I'm not going to get 0. I'm going to get a 1. So this would be 1 over 24 times 1. Go to your calculator, figure out what that is. I don't have time for that right now. For number 12, this might be an additional topic, because this is one of those funky u substitution ones that we have. Why don't you try it? We get 16/3, and if you have time, we'll do it in class. So let's try number 13 now. With number 13, cosine of 2x. So I do know that this is going to be u is equal to 2x, du is equal to 2 dx, so I need a 2. So I need a 1/2 out in front. So this is going to be 1/2. My integral. Now I'm going to show you how to change these limits as well. If I change these limits over to u, and I can do this both ways, I can go and back substitute in x and use the 0 and the pi over 2, or I can just use these limits with u. Well, I do know that if x is equal to pi over 2, this is my substitution right here. So then u would just be pi. If x is equal to 0, then u would be equal to 0 as well. So I'm going to go from 0 to pi, change of the limits, and you do have to know how to do this. And so then I have the cosine of u du. So now this is equal to 1/2. The antiderivative of the cosine is the sine. I'm going to evaluate from 0 to pi. So I get 1/2 sine of pi minus, now this 1/2 has to be distributed amongst both of these terms. So then this would be sine of 0. And I think that we end up with 0. Sine of 0 is 0, sine of pi is 0 as well, so that we just end up with 0. The last topic is the start plus accumulation. And I like to call this initial plus some kind of change. The integral is a change. So if I look at the definite integral written like this, I know that it's equal to f of b minus f of a. If I take this f of a and put it over on the other side, I'm going to be able to solve for f of b. F of b is equal to that f of a plus this. This f of a is kind of an initial value. So that's an initial value. This right here, the integral, is your change. We called it displacement. That's what it is. It is the change. So if they give me information, I can figure out possibly what a certain value is if I can find the change and my initial position. And I have all that stuff right here for number 14. So I do know that if I take the integral from 0 to 2 of, and I'll write this out, but you don't have to write this out, f of x dx, that's equal to f of 2 minus f of 0. They're asking me to find f of 2, so I want to solve this for f of 2. So f of 2 is going to be simply f of 0 plus my change. There it is, from 0 to 2, f prime of x dx. Notice this value right here has to match up with that value because my change is going from 0 to 2. So I have to know what the value is at 0. So f of 0 is 4. They tell me that. And then plus my f of x evaluated from 0 to 2. So I have 4 plus my antiderivative. I found my antiderivative, and I want to do the definite integral now from 0 to 2. So I go 4, plug in the 2. I get 8 plus 6, and then I'm going to subtract off. I like to put square brackets here. Oh, that turns out to be 0. That's kind of nice. So my f of 2 eventually is going to tell me that I got 12 plus 6, which I believe is 18 if I did it arithmetic right. Now this is a new method. So this is the initial plus change method that we can use. And the calculus people are pretty smart. They can make it so that you have to be able to use this setup. But we also could have used an old method. The old method was to find the antiderivative plus c. Go ahead and find c, and then go plug in the 2. And we would get the same exact answer. F of 2 is equal to 18, no matter which method you use. And like I said, the calculus people are very smart. They'll figure out ways that you have to do it this way, and you won't be able to do it the old method. But otherwise, you could do it either way. Last example, number 15. Oh, here's where they're very smart already. I don't know the antiderivative for this function, so I have to use my calculator. The calculator will set up the change for us. So if I say I want to know s of 3, which is what they're asking, and I have the velocity here, and I have some sort of initial position, I can say that I have s of 2 plus the integral from 2 up to 3. Notice that this value equals that value because I want to change from 2 up to my 3. And then the antiderivative, I would take 2 to the t dt. So then I can go ahead and say, oh, this is 8. This change, go to your calculator, and you can figure out what that number is. I got it as 5.771. In total, you're going to end up with 13.771. Make sure you can use the calculator on this. Find the antiderivative from 2 to 3 of 2 to the t dt. There's your answer. Okay, we use this theorem here, fundamental theorem of calculus, just messed around a little bit, and it can really help us a lot. The initial value plus the change. That's what we did. Initial value plus my change. All right, I hope you enjoyed this. I'm sorry it's so long. Have a great day.